All right, now what we're going to be looking at is rational expressions, and we're going to be simplifying these and then adding them and subtracting them, multiplying and dividing. So we're going to be looking at how to simplify rational expressions in different ways. Okay. So the first thing we want to do is just go over a quick thing with reducing these fractions. So reducing these rational functions. Now, if they're all by themselves, like this one is, it's pretty straightforward. You just take the common parts and reduce them. So we look at the leading coefficients, negative 27 over 9. Negative 27 over 9 reduces down to negative 3 over 1. Okay, so that's going to be the first part of our problem. Now we look at the next one, x cubed over x to the fourth, which, remember, when we're dealing with exponents and we're dividing, we subtract them. So 3 minus 4 is negative 1, which means it's in the denominator, leaving us with 1 over x. And then the next one, or the last one, y over y, gets you 1. It doesn't really mean anything. It just kind of, they cancel themselves out. And so now we're just going to multiply each of these together. And so that gives us a negative 3 over x as our answer for that one. So that's just simplifying it. Okay, so you take each one individually, each part, and then divide them through. Okay, so it's pretty straightforward. So now let's look at this. So now this one isn't as simple because it's not just two monomials over each other. We've got a binomial over a trinomial. And so what we're going to do here is that we're going to try to break these down. So if we look at the top part, what can we take out of both numbers in the numerator? The negative 6 minus 3x. What can we take out of both? Well, we can take out a 3 because 6 and 3, we can take a 3 out. But we're also going to take the negative out. Okay, just to get it and throw it out front. So when we take it and throw it out front, we get negative 3 is equal to x plus 2. And that's just me, once I take the negative out, all I did was I just kind of flip those around, which you can easily do. And now the bottom, let's try to factor. Two numbers multiplied together get you an 8. We got 1 and 8, 2 and 4. That's it. Two numbers multiplied together get you a negative 6. So that means both of them will be negative. So added together gets you a 6, would be 2 and 4. So that means we have x minus 2 and x minus 4. Okay. And now the question is, can we reduce anything? And the answer is no. We can't reduce anything, so it stays as is. But we've factored it out. And if there was anything the same on the top and bottom, we could cancel it out. But since there isn't, we just leave it as is. This is as far as we can go. Okay. All right, so now let's look at this one. So we're going to want to factor the top part. Two numbers multiplied together gets you a 2 times 2 is negative 4. Negative 4 added together gets you a negative 3, which would be negative 4 and 1. So when we factor, we got 2x squared minus 4x plus x minus 2. Group the first two, group the last two. You can take a 2x out, leave us with x minus 2 plus x minus 2. And we have a 1 sitting out front. Since these are the same, x minus 2 would be one factor, and then 2x plus 1 would be the other. Okay. So now let's factor the bottom part of it. Two numbers multiplied together get you a positive 6, added together get you a negative 5, would probably be x minus 2 and x minus 3. Okay. And so again, all we're doing here is we're just factoring, breaking those apart into two binomials. Now, do we have anything the same in both? Yes, we have x minus 2 the same in both, so we can take that out, and then we're left with 2x plus 1 all over x minus 3. And so that would be our simplified answer. Okay. So you factor the top, factor the bottom, see if anything reduces. If nothing reduces, just rewrite it. If something can, take those out, and then write what you have left over. Okay, now multiplying. Now multiplying these is pretty straightforward. All you're going to do is you're going to multiply across, just like when you multiply fractions, like 2 over 3 times 1 over 4. You just go 2 times 1, 2 all over 3 times 4, 12. Okay, and then you reduce from there. We're going to do the same thing here. But instead of just multiplying straight across and having to FOIL, we're going to see if we can factor anything out first before we have to FOIL. So if we look at the top part, can we break the top part down? Yes. Yes, we can. So we can factor the top part into x minus 2, x plus 2. Okay. This is the difference of two perfect squares. It's a little shortcut. And then in the bottom, we also have another difference of two perfect squares. X minus 1, x plus 1. Okay. Now we're going to factor the other side. The top can't be factored, so it's x plus 1. And then we're going to factor the bottom. What can we take out of both of these? We can take an x, leaving us with x plus 2. Okay. So now what do we have on the top and the bottom that are the same of both of these? Well, x plus 1, we can cancel those. X plus 2 are in both, so we can cancel those. That leaves us, once we've canceled these out, x plus 2, x plus 1, x plus 1, that leaves us with an x minus 2 on top and an x minus 1 times x on the bottom. And so that would be our simplified multiplication. After we've multiplied them together, that's what we get. Okay. So again, you're going to factor, see if anything reduces, then multiply them together. Okay. Now with dividing, you're going to do it just like if you were to divide fractions. Again, 2 over 3 divided by 1 over 4. Trying to think back, okay, how do we do this? How do we do this? You flip and multiply. So it would be 2 over 3 times 4 over 1, getting us 8 over 3 in this case. You're going to do the same thing here. So what I like to do first is I like to factor them first and then flip. So factoring the first one, two numbers multiplied together get you a negative 15, added together get you a 2, would get you an a plus 5, a minus 3, all over another difference of two perfect cubes or squares, a minus 4, a plus 4. And then the other one would be a plus 1 all over 3, a minus 4. And now, since we are dividing, we're going to flip the second one and then multiply them. So if we flip this around, flip the numerator and denominator, that gives us 3, a minus 4 all over a plus 1. Okay? And so that would be our new thing that we're going to multiply, and we're going to see is there anything that we can cancel out. Okay? And as you see, yes there is. We can take these out. And since that's the only thing we can reduce down, we just kind of keep it all together. And then from here, if you want to go any further, you would FOIL the top and bottom through. Okay, but that's as far as you have to go. You don't have to go any. You don't have to multiply it together if you don't want to. Okay, your IRATs. Simplify both of these. The first one's a multiplication, so factor all the parts down and then multiply them. And then simplify the second one, which is a division. So you're going to have to factor again, and then see if anything reduces, and then factor it down. Okay. So that's your IRAT. So this was simplifying rational expressions for these. Okay. So just simplify both of these, and that's it.